3 dice game. So consider a game in which you roll a single die. If you roll an even number, so we're talking about 2, 4, 6, you gain that number of points. And if you roll an odd number, so we're talking 1, 3, 5, you lose that number of points. So I'm going to put a negative here and I'm going to put a positive here just to remind me that we're gaining either 2, 4, or 6 points, or we're losing 1, 3, or 5 points. So it asks, show the probability distribution of points in this game. Okay, so we know that we're going to do X and then PX. Okay, so the number of points in this game, up more. Okay, we can have -1 point, or we can have +2. We can have -3 or +4, -5 or +6. Okay, and it's a die, so all of the probabilities, again, they're going to be uniform. They're all going to be 1/6. Now, so this right here is the probability distribution of the game. Okay, and now what is the expected number of points per roll? So now let's multiply X by PX. Okay, so -1 times 1/6, well, I get -1/6. I get 2/6, -3 times 1/6, 4 times 1/6, -5 times 1/6, and 6 times 1/6. And I always put a little like equal sign almost here, because 6 minus 5 is just 1, and 4 minus 3 is just 1, and then 2 minus 1 is just 1. So I get 3/6. Now we can reduce. Okay, again, don't reduce these numbers here, because to add them with a common denominator is so much easier. You just have to add the numerators. So I get 1/2. So therefore, the expected value is 1/2. And what that means is that every single roll that you take of this die, you're expected to go up 1/2. Okay, like I was saying before, 1/2 is not even an outcome. You're either going to get 1, 2, 3, 4, 5, or 6, positive or negative. So 1/2 is not even an outcome. But what this basically means is in 2 rolls, you're going to gain a point. In 4 rolls, you're going to gain like half that many points. Okay? Now, is this a fair game? So basically, the definition of a fair game, okay, so let's go fair game. Okay, definition of a fair game is basically 1-to-1. Okay, for every win, you lose. Okay, so 1 loss, 1 win, back and forth. That's a fair game. So both players come out with like the same amount. I always refer to money. So in this case, the outcome is 1/2. So one player is gaining, say, 50 cents per game. If this was in dollars, for example, 50 cents per game, 50 cents per game. Well, that's not fair to the person losing 50 cents per game. So in order to be a fair game, the expectation needs to be 0. But since it's not 0, so since the expectation is not 0, therefore it's not a fair game. Okay, one person's always gaining more points than the other. All right, now, example 4, canoe lengths. A summer camp has 7 4.6 meter canoes, 10 5.0 meter canoes, 4 5.2 meter canoes, and 4 6.1 meter canoes. And canoes are assigned randomly for campers going on a canoe trip. So let's just figure out a total number of canoes. So it's 17, 21, we got 25 altogether. Okay, now show the probability distribution for the length of assigned canoe. So X, and I didn't do the random variable X up here, but we actually should. So the random variable X, let X denote the number of points gained or lost. Okay, here X is going to denote, so let X denote the length of the canoe. Okay, so what are all the lengths? We have 4.6, you can be assigned that, 5.0, 5.2, or 6.1. Now, the probability of getting a canoe 4.6 meters long is 7 out of that 25. Okay, 5.0 is 10 out of that 25 because there are 10 canoes. Okay, 5.2 is 4 out of that 25 canoes, and 4 out of 25 canoes. Okay, so we have 25 as the denominator. Let's add. Again, this is 17. This is 25. Oh, sorry, one more step. This right here, I apologize, is the probability distribution. I need to erase that line. Now, what's the expected length of the canoe? So this here, if the question only asks you for the probability distribution, that's all you need to give. Now, the expected length of the canoe, let's actually multiply. Okay, so 4.6 times 7 over 25, it's kind of an ugly number. So I'm actually, it's 3 decimals. So I'm actually going to keep it, just put it as a decimal, okay? Because we're dealing with like a decimal and a fraction here. So let's go. I get 1.288. Okay, now 5 times 10 over 25, I get 2. That's a nice one. 5.2 times 4 over 25, I get 0.832. Now 6.1 times 4 over 25, I get 0.976. Okay, and remember, in order to find the expectation, what we have to, or the expected value, what we have to do is we have to add up all the sums of the xpx's. So just by adding up this entire column, that's what we're actually doing. 0.832, 1, or plus 2 plus 1.288. Okay, so we get 5.096 meters as the expected value. That means you're expected to have a canoe that is 9.096 meters.